Hello everyone. Topic of this poster is evolution of neutrino mass mixing parameters in matter with non-standard interactions. Main goal of this work is to explore the various role of various non-standard neutral current non-standard interactions in the evolution of oscillation parameters in matter. To do this, we diagonalize effective neutrino propagation Hamiltonian in matter in the presence of all possible neutral current non-standard interaction given by this matrix. We use a method of successive rotation to diagonalize this Hamiltonian, and while doing this, we derive the expression of three modified mixing angle theta 2 3m, theta 1 3m, and theta 1 2m given by these three expressions. We plot this modified theta 2 3 as a function of energy. Here, this three panel corresponds to the value of theta 2 3 in vacuum, and we can see that depending on the value of theta 2 3 in vacuum, the evolution is different in the presence of various NSI parameters. Similarly, in this plot, we show the running or evolution of theta 1 3m as a function of energy. The main features of this plot is that when theta 1 3m reaches 45 degree, the contribution from epsilon e mu or epsilon e tau vanishes. Similarly, in this figure, we see that the theta 1 3m saturates to a value near pi by 2 at very low energy. In the presence of epsilon e mu or e tau, this value of saturation shifts up or down, up or down. After the three rotation, the Hamiltonian is approximately diagonalized, and the three eigenvalues gives the three modified mass squares. We have plotted these two modified mass square differences as a function of energy. We can see that among these two mass square differences, delta m to 1 square m increases hugely with energy and can reach up to an order of 10 to the power minus 3, which is the same order of the value of theta 1 3m in vacuum. So using this expression of this modified oscillation parameters, we derive the expression of the energy at theta 1 3 resonance, or when theta 1 3 modified theta 1 3 become 45 degree, given by this expression, where this first term is the standard resonance energy condition or resonance energy term, and second term is the correction appears due to the presence of NSI. Finally, we analyze the role of NSI in the maximum nu mu to nu transition. So to study this, we use the approximation theta 1 to m goes to 90 degree and simplify this nu mu to nu oscillation probability as this, and find the condition for maximum nu mu to nu transition, which is given by this E resonance equal to E max. Using this condition, we derive the expression for the baseline length and the corresponding matter density, which will give the maximum nu mu to nu transition. Here, this term gives the correction that is appeared due to the NSI parameters. We have plotted this rho times L as a function of the strength of the NSI parameters. Various curves shows the various presence of various NSI parameters at a time. Among this curve, we see that in presence of epsilon e mu or e tau, there is a huge deviation from the standard interaction case. So to validate this result, we plot this nu mu to nu transition probability as a energy and baseline plane, and we see that indeed in presence of epsilon e mu and e tau, this region of maximum nu mu to nu transition shifts toward lower baseline or towards higher baseline depending on the sign of this NSI parameters. So finally, we conclude that using the expression of various modified oscillation parameters in presence of neutral current non-standard interactions can help us to study various important features related to the neutrino oscillations. Thank you.